Knowing any trig identity or having a triangle allows me to find other trig identities. So when I look at this problem and I want the secant of theta, it's much like the problems we did in section 3 with SOHCAHTOA, just expanding into the other trig ratios. Well, secant, remember, is... So first we want to think about secant. And secant is the reciprocal of cosine. So that means that the secant is hypotenuse over adjacent. So when I'm at this angle, dang, I know opposite and hypotenuse. So I need to do the Pythagorean theorem to find this missing side, which is my adjacent side. So I have 21 square roots of 2 squared, be really careful with your algebra there, is equal to 21 squared plus x squared. Remember, this square goes on both things. So when you square 21 and you square the square root of 2, you end up with 882 is equal to 441 plus x squared. When you subtract 441 from both sides, you end up with 441 is equal to x squared. And so you find out that x is 21. So now I can come in and I know my adjacent and I know my hypotenuse. And so my secant of theta is hypotenuse 21 over square root of 2 over 21. Be sure to reduce your fractions. So the secant of theta is the square root of 2. If we give you a trig ratio, we've given you enough to draw the triangle and then find the missing parts. So sine, we are going to need opposite over hypotenuse, but we know cotangent, which is adjacent over opposite. So draw your triangle. Let any angle you want be theta. So the adjacent side is 5, the opposite side is 12. We're missing our hypotenuse. So you can either find it with the Pythagorean theorem, or if you recognize 5 and 12 as one of your Pythagorean triples, then you know that this is 13. Once you've created your triangle, then it's easy to see that the sine of theta is 12 over 13. So this allows you to build the triangle. Pythagorean theorem allows you to finish, and then it's simply a matter of SOHCAHTOA or using your trig ratios after that. Now these look more difficult, but they're not. So the first thing is this looks scary. But basically this is just saying all values in one circle. Because we remember from our unit circle work that there are repeat values at different spots, those reference angles, around the circle. So we're going to go one time around the circle. So there's often 2 answers for these problems. So when we come in here, we want to solve for our trig ratio. So we undo multiplication by 1/4 by multiplying by the reciprocal, because dividing 1/2 by 1/4 is kind of messy. These cancel, so I have the cosine of theta is equal to 2. Now my first thought is, well, cosine is positive in quadrants 1 and quadrants 4. So I start to go to my unit circle to look at where this happens, but then I remember cosine of theta has to be less than or equal to 1 all the time. Therefore, there's no solution. We cannot have a value, a trig ratio for cosine greater than 1. Now cosine negative 1/2. Again, if you think about your unit circle, cosine of theta equaling 1/2, well, that's where theta, reference angle, theta is 60 degrees. But even easier, where is cosine negative? Cosine theta is negative in quadrants 2 and quadrants 3. And so if I use my reference angle, if I use my unit circle, I can just straight look it up. But I'm going to go straight to quadrants 2 and 3 because I know negative. If I use my unit circle reference angle here, I know it has to be negative. So I have a reference angle of 60 here, and I have a reference angle of 60 here. 180 minus 60 is 120. 180 plus 60 is 240. So those are the two places where cosine is negative 1/2. Good luck with your homework.